We're going to begin our next video in our exponential and logarithms unit here, specifically on how to solve equations with exponential and logarithms. But before we begin our lesson on properties of logarithms, I want to go back and recall something that we learned in a previous math course. Okay, remember the whole reason we needed logarithms is because they're the inverse of exponentials. So let's talk about some stuff we knew about exponents. For instance, if we had to multiply something like x to the 6th times x to the 4th, okay, we said, all right, x to the 6th is 6 x's being multiplied together, and if you're multiplying those 6 x's times 4 more x's, we would have a total of 10 x's. So this would end up being x to the 10th, okay? And so we see, or we develop the rule that when you are multiplying things with the same base, you end up adding the exponents. Okay. Likewise, we learned that if you expanded out x to the 6th over x to the 4th and you reduced any of the common x's, you would be left with 2 that didn't get reduced. So x to the 6th over x to the 4th is x to the 2nd. So the reverse of when we are multiplying, we end up adding the exponents. Well, when we're dividing, we end up subtracting the exponents. And finally, when we have an exponent that's raised to another exponent, if you multiply x to the 6th times itself 4 times, x to the 6th times x to the 6th times x to the 6th times x to the 6th, then altogether you end up with x to the 24th power. So that led to our rule that when you raise a power to a power, you end up multiplying the powers. Well, we'll have some similar rules for logarithms. Okay, first of all, the product property of logarithms says that if you have a logarithm, one logarithm, any base b, and in that logarithm is a multiplication, a product, then you can expand that out. The x and the y can each move out to their own individual logarithm, but they will be separated by addition. Just like with the exponents, when you're multiplying, you ended up adding them. Same thing with logarithms. If you have a multiplication in your logarithm, when you split them up, they are separated by addition. Okay, we have some examples over here that aren't necessarily relevant to you, although it might be interesting to you to sort of put these in a calculator. The log of 22, okay, and then compare that to what you get when you do the log of 2 plus the log of 11, because 2 times 11 does in fact give you 22. Then if you add log 2 plus log 11, you get the same thing as the log of 2 times 11, or log 22. Okay, we're not going to worry too much about this last column over here. All right, quotient property of logarithm says if you have a logarithm, any base, and there is a division in it, a quotient in it, then each one of those, the numerator and denominator, x and y, can go to their own logarithm, and this time, because it was division, they'll be separated by subtraction. And then finally, the power property of logarithms says if you have a logarithm with a power, that's a little hard to read, but that is x to the y power right there under the light. Okay, then that becomes a multiplication. In other words, the power y can move to the front as a coefficient, and it will be then y times log base b of x. So product property, if there's a product, separate them with addition. If there's a quotient, separate them with if there's a quotient, separate them with subtraction, And if there's a power, it becomes multiplication, so just think of it as becoming a coefficient in the front. So we've got two different types of problems that we're going to look at here. Okay, the first of which is expanding. I'm going to give you one logarithm. Like in this case, I have a natural log, one log with the base of e. It's got some multiplication and some powers and things like that in it. And we are going to expand this out until we have enough logarithms, however many logarithms it takes, so that each individual logarithm does not contain any multiplication, division, or powers in it. Okay, so the first thing I'm going to deal with, I think I'm going to do this in multiple steps, although eventually if you do this enough, you kind of get to where you can do it without quite so many steps. But I'm going to say that this logarithm has an expression raised to the 5th power. So the first thing that I'm going to do is bring that 5th power to the front as a coefficient. So it'll be 5 times the natural log of u to the 3rd times v. Okay, all right. Have I got enough logarithms yet? And I would say the answer to that is no, because I still have multiplication and powers in my logarithm. I want to keep going until I have no multiplication, division, or powers in my logarithm. All right, so let's keep going. This is 5. All right, now because there is a multiplication in this logarithm, I'm going to split this up to the natural log of u to the 3rd plus the natural log of v. All right, do I have enough logarithms now? Well, I have enough logarithms. However, there is one more thing I could expand, and that is that the natural log of u to the third contains a power. Okay, so that u to the third power can come to the front of its logarithm. So I'll have 5 times 3 times the natural log of u plus the natural log of v. Okay, now there's nothing wrong with this answer as a final answer, but we do have maybe some simplifying we could do here. We could possibly do some distributing. If I distribute the 5 to both of these, I would have 15 natural log u, and we'll remove those parentheses because in this case there's just not any reason for them to be there. And then I'll distribute to the 5 to this one and have 5 natural log v. Okay? So again, I have enough logarithms and I have everything expanded out fully such that each of my individual logarithms, both this logarithm, natural log u here, and also this logarithm here, natural log v, neither one contain any multiplication, division, or power, so I know I'm done expanding. Okay, next one. Okay, all right, I see a multiplication, so I'm going to do log base 9 of a to the third plus log base 9, b to the third. Sorry about that, really bad handwriting there. All right, both of those contain powers, so 3 log base 9 of a plus 3 log base 9 of b. That is messy, I apologize, but you kind of got the point there. All right, both of these logarithms, log base 9 of a here contains no multiplication, division, or powers, and also log base 9 of b, same thing, so I'm done. Okay, a couple more of these. Sometimes they're not even going to contain any variables, and we're just going to do the same process. Okay, we'll have 6 times log base 9 of 3 to the 5th times 10, and 6 times, okay, split this up, log base 9 of 3 to the 5th plus log base 9 of 10. Okay, still have a power here in the first logarithm, so 6 times, 5 times log base 9 of 3 plus log base 9 of 10. All right, I think that's all the expanding we can do. Now there's a couple things we can simplify here. I can distribute the 6, so we could have 30 log base 9 of 3 plus 6 log base 9 of 10. All right. Now, depending on what teacher you're learning or what you're looking at here, let me move that out of the way. Okay. All right. There is one more possibility of something that could be simplified here, and that is log base 9 of 3 is actually one that we can evaluate. I can't do anything with log base 9 of 10 because remember the whole concept behind a logarithm is what power could you put on 9 to get 10? That's not going to be a whole number or a fraction or a decimal, okay? But log base 9 of 3, I could actually simplify. What power could I put on 9 to get 3? Well, the square root of 9 is 3, so the power would be 1/2. All right, so I'm going to bring this up here to the top and say that this is 30 times, if log base 9 of 3 is 1/2, I can replace that plus 6 log base 9 of 10. All right, and then I can multiply 30 times 1/2 and get 15 plus 6 log base 9 of 10. That would be a great final answer for that one. All right, finally one more. Okay, I'm going to go through this one a little bit more quickly. All right, we have 6 times log base 6 of x y to the 6th. So 6 times log base 6 of x plus, I'm going to skip a step here. Instead of log base 6 of y to the 6th, and then I'm going to go ahead and put that 6 in the front. 6 times log base 6 of x plus 6 log base 6 of y. Sorry, this is so messy. All right, and then I can distribute 6 log base 6 of x plus 36 log base 6 of y. That would be a good final answer for that one. All right, now we're going to take this the other direction. We're going to take an expression that contains more than one logarithm separated by addition or subtraction or possibly with a coefficient in the front. Okay, and then we're going to condense it all into one. And again, here in the beginning, I'm going to show multiple steps. After a while, you might get to the point where you don't need this. All right, excuse me, in both of these cases, I see a coefficient in the front. Okay, so where did that coefficient come from? It came from the fact that there was a power. Okay, so this is log base 9 of 8 to the 6th plus log base 9 of 3 to the 4th. Okay, all right, I also see that these logarithms are separated by an addition. Where did the addition come from? The addition came from the fact that the single logarithm contained multiplication. So I'm going to write this all as one logarithm, log base 9 of 8 to the 6th. And again, this addition came from the fact that there was a multiplication there, log base 9, sorry. It's not working. Log base 9 of 8 to the 6th multiplied by 3 to the 4th. Now, if those had been some smaller numbers, I may have asked you to multiply that out, but we're not going to worry too much about that. But whatever 8 to the 6th times 3 to the 4th is, that would be, if you fully simplified it, that would be log base 9 of that really large number. All right, one more of these on this page. Log base 6 of a to the 5th minus log base 6 of b to the 4th. All right, now this time we have subtraction in between the logarithms. What does that mean? That means there was multiplication in the single logarithm, okay? So a to the 5th was being divided by b to the 4th, okay? All right, two more quick examples of this. All right, I see log base 9 of x plus log base 9 of y, but this one can be log base 9 of z to the 3rd. Okay, and then in one logarithm, that would be log base 9 of x multiplied by y multiplied by z to the 3rd. Okay, all one logarithm. All right, and then finally, log base 6 of 3 to the 30th minus log base 6 of 8 to the 5th. So log base 6 of 3 to the 30th, this one has subtraction, so it came from division, divided by 8 to the 5th. And again, if we had a calculator, we might simplify that a little bit, but right now we're not going to worry about that.